Oh, this is awkward. Okay. How do we do this? Okay. So, hello. We are here today to explain to you lecture quiz number 1. Yeah. So I'm joined today with my teaching assistants Enoch and Risa. Yeah. All right. So we're going to go through. Not every question, but most of them. Some of the questions will combine together. We'll talk about some options briefly, but we'll spend a bit more time on the options where most people get wrong. Okay, so we'll tell you why it's wrong, and then we can learn together. All right. Now, I want to start by saying that for this module, we make it a point to explain quiz questions with videos so that you can learn. And every time we do this, it means that we cannot recycle quiz questions. It means that next semester we have to write more quiz questions again. It's a lot more headache for us, but well, I hope that you learn from this experience. Okay, so let's begin with the first question, section 1. So section 1 has two variants, right? One of them is asking, what is an objective? The other variant is asking, what is a problem? So let's explain the options.
Alright. So, if we look back at lecture 1, we'll find that an objective is essentially the way or the approach that you use to solve a problem. And there can be many ways for you to solve the same problem. So when we look at the first question, what is an objective, we find that options 1 and option 3 are the correct options. The problematic option here is option 2 and option 4. Why is that so?
Okay, so for option 2, it's about the objective is the situation that you are trying to solve. So in the lecture videos, we actually say that it's actually the problem is the situation you're trying to solve, not the objective. And the fourth option is objective is something you're trying to achieve, like an A+. So the reason why that is not an objective is because it's merely a statement and there's no given approach to actually on how you want to achieve that A+ for the module.
Okay.
Alright, so let's move on to the next question, the next section, which is problem versus objective part 2, right? So in this question, we got two variants. So let's start with variant number 1. In a problem Betty is facing, Betty has adopted the objective, I will exercise thrice this week. Which of the following statements are possible problems she could be trying to solve? She wants to lose 15 kg from freshman 15. She's going to do exercises for her core and thighs. She hopes to build up her core strength and thigh muscles. She's not fit, but her crush likes fit people. Ooh.
Okay, so as you can see, the correct options are 1, 3, and 4. So the reason why 1, 3, and 4 are the correct answer for the problems because it states the desire of wanting to solve something. However, option 2 is not the right answer because it states concrete actions of what you want to do, so doing exercise for her core and thighs.
For question 4, we see that there are 4 options. He needs to get an A+ for this test. He will spend 5 hours revising the lectures and tutorials. He's going to ask his professors on all the content he doesn't understand. And he wants to be less busy with all the CCAs. And so the question is, which of these are valid objectives that he could use to solve this situation? The correct options are 2 and 3. These are clear, concrete action plans that he can take in order to solve this problem. On the other hand, for options 1 and 4, these are needs and wants. These are statements of a problem, but not a method in order to achieve what he wants to do. As a result, we find that the only correct options are 2 and 3.
So I hope by now you understand that when we talk about problems and objectives are always have very, very concrete specifications of what we want to do. Yeah, a problem is always something that is very vague. It's a problem because you still don't know what you want to do, right? So the objective is how we want to solve it concretely. Alright? Okay, let's move on to the next section, which is about computable problems.
Okay, so in the lecture videos, we learned that technically all problems could be computed well if you can formulate a set of instructions to transform these inputs into the desired outputs. However, in reality, we all know that not all problems are easily computable. So these questions are trying to identify the problems that cannot be computed well. So most of you answered it correctly. Most of you chose these 2 options, which is the problems too broadly defined, and the problem involves subjective taste, feelings, and opinions.
These options are correct, but they are incomplete. The first 2 options are also ways to identify problems that cannot be computed well. The first says, the problem cannot be easily abstracted into a simplified model. Now recall the lecture. The purpose of abstraction is to remove irrelevant details so that you can model the problem and devise a plan in order to solve it computationally. If you cannot abstract the problem easily, you can't create a good model, and you'll find that you have problems trying to apply computational reasoning to solve the problem and compute it well. The second option is also another problem that cannot be computed well. Abstracting the problem is easy, but if it removes important considerations that render the solution ineffective, you find that the problem actually remains unsolved. And you can hardly have said to have computed a problem well in that scenario.
So some of you have asked on the group chat, and I gave the analogy, right? Just because you can cook doesn't mean you can cook well, right? You know, some people you eat that cooking, you get food poisoning and diarrhea, right? So same idea applies lah. Alright, okay, so let's move on to the next question. Which of the following problems cannot be computed well? So let's go through all the options that appear in all the question variants, alright? Shall we? Let's go.
It is quite clear that of the 4 options given, 1 and 4 are the ones that cannot be computed well. You watched a video about the horrors of factory farming and you are now thinking of becoming a vegan. This is a subjective feeling or taste or even an opinion. The second option that cannot be computed well is number 4. You want to go overseas for an exchange but face opposition from your parents who are worried that other countries may not be as safe as Singapore. Once more, something subjective, a taste, a feeling, an opinion. So these 2 are the options that cannot be computed well.
Okay, so the next 4 options, as you can see here, the correct answers are 1, 3, and 4. So question 1, you just turned 21 and the elections are coming. The candidates have made so many promises and you struggle to determine which candidate to vote for. So the reason why it can't be computed well is because it's too broadly defined. So you can't really determine which candidate to vote for, so that is not really a problem that can be computed well. And the next option, which is option number 3, so you know, this scenario, you lose to your younger sister in Super Smash Bros. And you feel humiliated, and you want your help, you want like this person's help to help you win against your sister. But once again, it's also too broadly defined, because you don't really know specific strategies on how you want to beat your sister in the next round. And the last option number 4, which is a bit problematic, which I'll explain why. So Rachel is writing on the topic of stigma against migrant workers for a blog assignment. She wants to find 20 migrant workers who have faced stigma and interview them. So the reason why this problem cannot be computed well is because the topic of stigma is also another problem of being too broadly defined. It's very hard to find people with stigma because there's many kinds of stigma and it wasn't really stated in this statement. And so this leaves us to option number 2 of why this can be computed well.
So as you can see, right, issues that are very subjective, issues that are very broad, yeah, they cannot be computed well. Why? Because, well, in the first place, if it's subjective, what applies to me doesn't necessarily apply to everyone else. If it's too broad, it's what we call intractable problems, right? So we do not know. There's too many ways to solve the thing, to address the issue. You can't really come up with a good model to address it universally, right? So these are the things that make it hard to compute problems well. That being said, in this module, in this world today, a lot of people are trying to compute problems that can't actually be computed well. And in this module, we want to highlight. Oops.
It's okay.
Yeah. Okay.
Still alive, still alive.
Chinese New Year Panda is doing fine. Do you know this guy? Okay, anyway.
Wow.
Yeah, okay. So anyway, what was I saying? Yes, intractable, computable problems.
Yes.
Yeah. So you cannot why do we want to highlight to you problems that can be computed well and problems that cannot be computed well? Because in this day and age, there are people who want to use computational methods, computational tools to solve problems that cannot be computed well. And we want to highlight to you how this will result in a lot of social and ethical problems. Yeah, so this is one of the focus. Yeah, so of course, computable problems, no issue, right? So there's nothing to talk about. But it's all those things that cannot be computed well. But we can get the false sense that we can compute them. So what's the issue? That is something we'll look out for in the weeks to come. Right? Anyway, let's move on to the next question, shall we? Section 2, computable problems, part 2. Alright, so what is the question asking is, which of the following problems can be computed well? We have a bunch of options, so let's go through all these options.
There are 4 options given to us, and the correct answers are actually 2 and 3. These are the ones that can be computed well. Now, why is that so? We see that for the wrong options, for 1 and 4, the first one says, you and your friends had an argument over whether climate change is real. You desperately want to convince your friends of your position. But this is still something subjective. It is your feeling, your taste, your opinion, and you might not be able to easily find a way to compute this problem as a result. For the fourth option, Ben just learned that he failed several important modules and you're trying to comfort him. This is a very broad problem. How are you going to abstract away and create a simplified model in order to solve this problem computationally? It is simply difficult.
Okay, onwards to question number 9. So, the correct options are actually 1 and 4. And like his approach, I'll also be explaining why options 2 and 3 are wrong. So option 2, so the option is, Sarah noticed that her group mate copied off part of her essay and wants to tell the tutor. She is worried that the group dynamic will be strained if she does so. So why this can't be computed well is because regarding group dynamics, it's something that requires a very, very subjective, a lot of emotions that are running high and all of that. So it's very hard to build a model to help to abstract this problem.
There's no one-size-fits-all solution, in other words, yes?
Yes, correct. Okay, and option number 3, you and your friends want to watch a movie together on Saturday, but everyone can't agree on the same movie to watch because of different interests. And keyword here is different interests. So you also, same thing, there's no one-size-fits-all, because all of us have different interests, it's subjective, that's why it can't be computed well.
Moral of the story, get better friends to watch movies with. Is that a one-size-fits-all solution? Does that make the problem computable? I leave you to decide, alright?
Do you have friends?
Ouch, Lisa.
Okay. Oh! Okay. Alright, so moving on, what do we have next? Next question, is it?
Constraint and optimization approach.
Yes,
definition.
okay, so this is section 3, constraint versus optimization. The lecture videos discuss the definition of the constraint approach and optimization approach. So here are statements about both approaches. We'll talk about each option and tell you whether it's a constraint approach or optimization approach. Alright, so let's go.
Alright, so the very first option says both approaches are mutually exclusive. You can't use constraints if you're already using optimization and vice versa. Now, this is definitely false. We have already learned in a lecture that you can actually use constraints on top of an optimization approach, or vice versa. So you can't say that they're mutually exclusive. The second option says a constraint approach imposes an absolute limit on something in order to solve the problem. Now, this is a true statement. A constraint imposes an absolute limit, an upper limit or a lower limit, so that you're able to solve the problem.
And so option 3, optimization approach can include constraints. So actually if you read the question in option 1, if option 1 is wrong, option 3 is correct because optimization can include constraints. And for the last one, an optimization approach seeks to maximize or minimize something in order to solve the problem. So this is true for the optimization approach. It's different than the constraint approach because constraint approach is about limits, absolute limits that you cannot break.
Let's move on to Section 4, solving problems with constraints.
So the first question says, which of the following statements utilize constraints in their problem-solving approach? The correct answers here are 1 and 2, and we can see that there are very clear absolute limits that have been placed. In the first option, the limit here is the 50 km per hour speed limit. In option 2, Bruce's gamma ray project budget is 5,000. That is his absolute limit. So these two use a constraint approach. Options 3 and 4, on the other hand, use optimization approaches. Clint wants the most fanciful restaurant he can find for dinner, and Jane wants to spend as little as possible. These are, respectively, attempts to maximize or minimize something, making them optimization approaches.
Okay, and now moving on to the next 5 options that you can see here. So the correct answer is option 1, 2, and 5, and I hope you guys get the references in the questions. Anyway, so for options 1, 2, and 5, you can see, like what Enoch said, there's been limits that have been set. So for example, for Tony Stark, Tony Stark, his doctor already prescribes a limit of taking an iron pill after breakfast and dinner, and he strictly follows it. Yes. And option number 2, the limit here is that she has to leave in 10 minutes. And in the end, she's able to finish it just 1 second off 10-minute mark, but she still does it within the 10 minutes. And the last option, option number 5, Peter wanting to overcome his fear of heights. There's an imposed limit of taking a cable car at least once a month. Okay, so why options 3 and 4 are wrong? So example for option 3, working overtime every day. There is no limit that's there. Option number 4 is also another similar thing. So although her trainer suggests her to eat twice, than what she normally eats, Carol actually exceeds that and actually eats twice more than what she normally eats. That's why it's not a constraint approach. Okay, so the last variant, let's look at the 5 options here. So most of you actually included option 1, which is Tony wants a device that can track his diving location as deep as possible. In the end, he can only invent a device that can track his location up to 20 meters below sea level. Okay, so the reason why this is not a constraint is because the fact is, example, as deep as possible. There was no limit that was actually set.
So to be clear, the limit is within the device, not in the way he is solving the problem, alright? So he's still trying to optimize, and right now his optimization takes him to 20 meters, yeah?
Okay, so the correct options here are actually option 2 and 4 and 5. So as you can see, for 2, 4 and 5, so 2, there's this vow to practice 7 hours a day, so there's this limit that's already set. For option 4, it's already said that she has to work 2 more, so she works 2 more. So this is in fact her again following the limit that's there. And for option 5, it's also because it works as much as he can until he has saved enough money. So this enough money is actually that constraint that's already there.
Option 3 says, Steve promised to meet Bucky tomorrow to travel to Malaysia, but he also realized that he promised Peggy to watch a movie together. And Bucky and Peggy don't get along, so he doesn't know what to do and he stays at home and feigns illness to avoid choosing Bucky and Peggy. But there's no constraint given over here.
No constraint.
No constraints at
No
all.
optimization either. This fella's just staying at home, yeah.
He just can't make up his mind.
Yeah. Oh, okay.
Yeah.
Alright.
Yeah.
Okay.
Now, I do want to clarify. For option number 5, even though didn't set a very specific what is that enough money, there is a sense that there's a constraint. So in Peter's head, he has already a sense of what that amount is already, right? Okay, next question, which is section 5, solving problems with optimization. Again, we'll go through all the options in all the variants. So let's begin.
So you can see in option 1, Brian having $10 at the end of the day, really hungry, wants to buy a $10 extra large burger. But in the end, he buys a $2 small burger so that he can save up for the buffet with his friends on the weekend. So the reason why this is an optimization approach, as you can see here, he has this $10 and he is hungry, he can buy the $10 extra large burger. But then he optimizes because he has this criteria of also wanting to save up money for his buffet with his friends on the weekend. That's why he buys a $2 burger instead. Okay, so option 2 is a bit problematic, and I'll explain why. So Liam wants to buy flowers for his date, but doesn't know if she likes blue or red flowers. In the end, he buys both blue and red flowers, hoping that his date will like it. Okay, so for this option, in hindsight, when we look at it, we realize that the optimization criteria wasn't actually specifically set.
Yeah, it's not very explicit,
yes.
so there's an interpretive leap required to see the optimization. So because of this, oh, you know what's the good news? All of you, whether or not you got this question or the other questions, you get free 2 marks! Yeah! Okay, so yeah, so our mistake is your happiness. Okay, so anyway, so we made a mistake here in the phrasing. Whether or not you got the question correct for this last section, you get full marks for it anyway, the 2 marks. So, but what we wanted to actually do with this option was that we wanted you to see that the person in wanting to be, kiasu, right? Typical Singaporean, right? Oh, my panda dropped again. So,
Third time already.
yeah, this is the Chinese New Year panda, right? Just for Chinese New Year. 恭喜发财. You know what 恭喜发财 means? I hope you get rich, right? That's why we're wishing everyone doing Chinese New Year. I hope you get rich. I hope you get rich. 恭喜发财.
恭喜发财 to you.
Yeah, okay, yeah. Hope you get rich too. Okay, anyway. So nonsense. Okay, anyway, so so what was I saying? Oh yeah, before the panda drop, I wanted to say, so in this question, we wanted to show you that the person is being kiasu, want to be kiasu, so optimize by going for all options available, maximizing all the options so you cannot go wrong. But we realized on hindsight after releasing the question that this intention is not explicit. So not to penalize any of you, you get the free 2 marks. Okay, anyway, so I hope you had fun learning together with us. That's all the questions that we covered for lecture 1. Stay tuned, we will have another video for lecture 2 quiz. So bye bye. Oh, wait. Happy New Year. Don't forget, if you're going to buy 4D, the lucky number is 1050. Hwala! Okay, so hwala. Bye-bye. Bye-bye.
Bye.
See you.